This is the 4-4 and 4-7 review. Calculators still are not allowed, and this is the free response, number 6. So you're going to be graded a lot on the work for this, and you'll need to be able to show the process all the way through. So first, let's just read the problem. I have a function, f of x equals 8 minus x squared. So that's a parabola that opens down and has its vertex at 0, 8. Then we're looking on a domain that's given to us. That's good. We won't have to find it. And we're going to have a of w represent the area of the triangle that is formed by the coordinate axes and the tangent line. So we're looking at this triangle right here. Now if we read part A, we want to find the area of that triangle when w is 2. And if we read part B, it says for what value of w is that area of the triangle going to be minimized, and we want to justify. So I'm actually going to set up my formula for the area of the triangle and then plug 2 in, as opposed to doing all the work for when w is 2 and then repeating it for the general case. So I'm going to just do the general case up front. That means I need to write a formula for the area of this triangle. We can write down that the area of that triangle will be 1/2 times the base times the height. Our job is to get the base and the height in terms of this w. So if we look carefully, we can see that the base is actually the x-intercept of the tangent line. So that means we'll be 1/2 times the x-intercept, and then the height of that triangle is the same as the y-intercept. So we're going to be able to find the x and the y-intercepts once we have the equation of the line. So in order to write the equation of the line, I'm going to need a point, and I'm going to need a slope evaluated at the point. So again, we can look and see that the point is w, 8 minus w squared, and we can see that the slope will be the derivative of f evaluated at the point. So the derivative of this is a negative 2x, and we need to evaluate it when x equals w. So my slope is a negative 2w. Again, this is where I will slap you down and stop grading if that slope has an x in it, because when you write the equation of the line, you need the slope that goes with the point. So now that we have the point and we have the slope, we can write the equation of the line, which is y equals the slope times x minus the x coordinate plus the y coordinate. Now that we have the line, we can start to figure out what the x-intercept is and what the y-intercept is. Remember, with the x-intercept, that it's the y-coordinate that is 0. So we plug in a y equals 0, and now we need to solve for x. Now there are a variety of ways that we could do that. I'm just going to move these two. Actually, you know what? I think I'm going to multiply through so that I don't have fractions as much. So I'd have a negative 2wx plus a 2w squared plus an 8 minus a w squared. Now x is what I'm trying to get alone, and it's currently negative. So if I move this to the other side, I will start to eliminate the number of negatives that I have to keep track of. I can also combine these like terms and get a w squared plus an 8. So if I want to isolate x now, I will divide by 2w. And you can get to this answer multiple ways, but this particular way is probably the most efficient and the one that is less likely to cause errors. So we've got our x-intercept now. We also need our y-intercept. So to find the y-intercept, that's when we let x equal 0 in the equation of our line. So that means we'll have y equals a negative 2w times a 0 minus w plus an 8 minus w squared. Notice that that y-intercept gives us a 2w squared minus a w squared. That's a w squared plus an 8. And it kind of looks like this one, which means our formula for the area of that triangle will be 1/2 the x-intercept times the y-intercept, which ends up giving us a w squared plus 8 squared on top, and a 4w on the bottom. So now we've got a formula that we can use for the area of that triangle for any value of w. Part A says, what is the area when we plug in a 2? So a of 2 will be a 2 squared, which is a 4, plus an 8 squared over a 4 times a 2. I end up with a 12 squared, which is a 144, over an 8, which reduces down to an 18.